In this video, we're going to learn more about mixed numbers and improper fractions. So this here is a mixed number. And if we look at this mixed number here, we have a whole part of our mixed number, and we have a fractional part of our mixed number. So we're familiar with fractions, and if we were to read this fraction, just ignoring that whole number for just a second, this fractional part is 2/3. Now we know how to read whole numbers. We read this 3. So when we read our mixed number, this is a mixed number with a whole part and a fractional part. This mixed number is 3 and 2/3. Say it with me. 3 and 2/3. If we were to look at a model to represent 3 and 2/3, this mixed number, first off, we will be talking about thirds. We would be looking at this right here, just like if we were just looking at this 2/3 right here, and we wanted to model 2/3, we would be dividing each of those bars into 3 parts. So if we had started with that 3 parts there, and we had started with 2/3, after that, we would look at this here, and then we would be all, okay, well, we colored in 2/3, we would look at these 3 holes, and then we would have added 3 more bars. Whether or not that we had separated those out into thirds, it's entirely up to you. Could have modeled it either way. But in this case, if we have 3 holes, that's 1 hole. Each of these bars represents a hole. 2 holes. And 3 holes. So, we have just modeled 3. 1, 2, and 3. And then this is the fractional part. 2 out of those 3 parts are shaded. So you've got 1, 2, 3, and 2 out of the 3 parts. 3 and 2/3. We'll notice as we have the model up that we are talking about thirds, and we could write an improper fraction for this mixed number. An improper fraction for this mixed number. In other words, we could describe this mixed number as thirds. And how many thirds are in this mixed number? Each of the wholes is worth 1, 2, and 3/3. So we've got 3/3, 6/3, 9/3, 10, and 11/3. And I'll go ahead and write that in. So 3 and 2/3 does equal 11/3. Here's your definition for a mixed number. It's a number containing a whole part and a fraction part. So 3 and 5/8 is a mixed number. Take a moment to copy that definition down for yourself and write a couple more examples of a mixed number. Your fractional part has to be that the numerator is less than the denominator. Those are all mixed numbers. We can read them too. This is 3 and 5/8, 6 and 2/3, where there's a whole part and a fractional part, and this is 5 and 2/5, that fractional part being 2/5 and the whole part being 5. I have a definition for you of an improper fraction. It's a fraction that is greater than or equal to 1. The numerator in an improper fraction is greater than or equal to the denominator. Remember, the numerator is the number above, and the denominator is the number below. So 5/3 is an example of an improper fraction, just as 7/2 is an example of an improper fraction. And then what we can do is we can go ahead and convert these improper fractions to what it is that we've been talking about. It's a mixed number. And then so, I'm just going to go ahead and do these for you. 7 divided by 2 7 divided by 2 is 3 wholes. This makes sense because 3 wholes is worth, each whole is worth 2 halves, so 3 wholes is worth 6 halves. And then we had a remainder of 1 though, and then we were talking about halves. That denominator stays the same. 3 goes into 5. We're talking about 5/3. 3 goes into 5 1 whole time. We're still trying to talk about thirds. In other words, that denominator is going to stay the same. And we have 2. 2 was a remainder. So we had, this is what I was talking about. 5 divided by 3 is equal to 1 with a remainder of 2. And that denominator stays the same. Just like we had for the other one, 7 divided by 2 equals 3 with a remainder of 1. It goes in 3 whole times. With that remainder of 1, if we could divide this 1, we would have divided it by 2. That's what this is right here, 1/2. 7 halves, 5/3, improper fractions. Take a moment to write that down for yourself as your definition for improper fraction. And I just showed you how to change an improper fraction back to what this video is about, mixed numbers. Again, from our previous screen, 7/5, when we think of 7/5, we should be thinking about 7 divided by 5. 5 goes into 7 1 whole time. 1 whole time. And that's why we have 1 whole right there. And then we have 7 1 whole time with a remainder of 2. The denominator stays the same. And that 2 goes right there. 7/5 equals 1 2/5. Now, when we had thought about this, if we were going to draw a model for this, 7/5, we would draw a unit bar. We would divide it into 5 parts. And then we would color in 7 of those parts. 1 part, 2 parts, 3 parts, 4 parts, 5 parts. Uh-oh, nothing more to color in. Oh, I already colored in 1 whole. I colored in 5 so far. I'll draw another unit bar. Again, 5 parts. And again, 1, 2, 3, 4, 5, 6, and 7. So that right there, our fractional part, is right there, 2/5. And our whole part of our mixed number, 1 whole. 7/5 equals 1 2/5. 1 2/5 also equals 7/5. 1, 2, 3, 4, 5/5, 6/5, 7/5. It works both ways. Let's look at this another way. First off, let's read this mixed number. This mixed number is what? Right, 6 3/4. 6 3/4. Now, if we just look at that whole portion, 6, I think you'll agree with me that we could rewrite 6 as 1 plus 1 plus 1 plus 1 plus 1. And then we would just have our fraction there as 3/4. So we had 1 plus 1 is 2, plus 1 is 3, 4, 5, and 6. Now if we thought about that, and thought about each of those wholes, each of the wholes is worth how many fourths? Each of the wholes is worth how many fourths? Might help to look at a model. Let's think. I've shown you 2 unit bars, and then so each of these unit bars is worth a whole. So 1 whole is equal to how many fourths? 1 whole is equal to how many fourths? How many of these would we have to shade in to equal 1 whole? Right, the answer to that is 4 of them. We would have to shade in 4 of them to equal 1 whole. So each of these wholes is worth 4/4. Each of these wholes is worth 4/4. And then so I'll start writing those in there. Each whole is worth 4/4. Remembering our 3/4 there as well. And then so 6 3/4 is just equal to that string of numbers right there. How many did we have of these wholes? 6 of them. So 6/4 is just 6 times 4. 6 times 4, fourths. 6 wholes is 6 times 4 fourths. And then we remember to add in our fractional part there. 6 times 4 is 24. 24 fourths plus 3/4, which does equal 27 fourths. So 6 3/4 as an improper fraction is 27 fourths. There I place the model representation for 6 3/4. 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 6 and 1, 2, 3, 3 out of 4, 6 3/4. Now if we looked at this here, and this had been fourths, remember each whole is worth 4/4, 4/4, 8/4, 12/4, 16/4, 20/4, 24/4. Doesn't that look familiar? Plus that 3/4, which does equal 27/4 as an improper fraction. All right, it's time for you to try. The instructions are write the improper fraction for each of these mixed numbers. Read them with me. 3 1/6, 5 4/7, 2 1/2. Go ahead and hit pause and write those improper fractions. Remember, the denominator is going to stay the same. All right, that denominator is the same. 3 wholes. 3 wholes is worth how many sixths? 3 wholes is worth how many sixths? Right. 18 is correct, where we multiplied 3 times 6. And then we added back that 1/6. So 3 times 6 is 18, plus 1 is 19. So we have 19 sixths. If we checked our work, 19 divided by 6 is 3, with a remainder of 1. 3 1/6. If we could divide that 1 remainder, we would divide it into 6 parts. I've written in my numerator already as those 5 wholes. We are talking about what? Sevenths. 5 wholes are worth 35 sevenths, or 5 times 7 sevenths, and then we add back in our 4. 35 plus 4 is 39, 39 sevenths. I'm just going to write in my answer for that last one there. My answer is 5 halves. Draw a little model for you. There's 1 hole. There's 2 holes. And then this last hole will divide into half. And we would shade in only one of those 2 there. 1 hole, 2 hole. We have that there. And just to make it a little bit more clear for you, I'm going to go ahead and separate those first 2 there into their halves. So if I count it out, 1/2, 2 halves, that's a whole. 3 halves, 4 halves. And 5 halves. 5 halves equals 2 wholes, 1 whole, 2 wholes, and 1/2. I'll do that first one with you, and then I'll let you go ahead and work on those last 2 yourself. These will be you tries right here. 13 sevenths. 7 goes into 13 1 whole time. Again, we'll keep that denominator the same. And the remainder would have been 6. So 13 sevenths equals 1 6/7. Again, I was thinking about 13 divided by 7, and that's 1 with a remainder of 6. If I could divide that 6, I would divide it by 7. That's why I have this here, 6/7. Again, the denominator stays the same. You try. Pause the video. You try. Did you come up with 7 1/2 for 15 halves? 23 divided by 6. 6 goes into 23. 3 whole times. with that remainder of 5. 3 and 5/6. And then so what we were doing here is that we were converting improper fractions to mixed numbers. Get ready, get ready. Go ahead and point at the mixed number. Read it. Ideally, you're pointing at 6 2/3 right here. Point at the improper fraction. Right, you better be pointing over here. There's really nothing else to point at. And how do we read this improper fraction? Right, 17/5. Where what's in our numerator? Right, 17, and this is fifths here. Now, if we looked at 17/5 again, we think about 17 divided by 5, which goes in 3 whole times, with that remainder of 2. So we can convert improper fractions to mixed numbers, just like we can convert mixed numbers to improper fractions. 1 whole is worth how many thirds? Right, 3. So 6 wholes is worth how many thirds? 18 thirds. Or that's 6 times the 3. And then if we add it together with that 2 thirds, we get 20 thirds. What is it that we're doing on this top line? We're converting a what to a what? Right, mixed number to an improper fraction. And this is an improper fraction to that mixed number, showing you the relationship in between the two.